Good morning, students of geometry. Your assignment today is to prove the vertical angles theorem. In other words, given two intersecting lines, show that two angles that are opposite each other are congruent. On a test, I will give you two intersecting lines. I will label 5 points on those lines. And then I will tell you specifically, prove that angle QTP is congruent to angle RTS. Now, in this example, that's what I chose. Show that those two are congruent to each other. I didn't have to. I could also ask you to prove to me that angle QTR is congruent to angle PTS. So you have to be prepared for any possibility. You have to be prepared for any set of points. I will give you 5 points. If I were you, I would start out with a drawing of two lines, and I would put dots where those points are. And I would practice until this happens naturally. I want you to use a flow proof for this. In other words, a bunch of boxes and arrows. And let's get started. My plan, here's my plan real quick. I'm going to show that, first of all, that QTP and QTR form a linear pair. And then I'm going to show that QTR and RTS form a linear pair. And then what I'm going to do is I'm going to say, let's take away some of this. Let's take away just this much. And since we're taking away the same amount from both of those 180-degree pairs, we know that what remains must be congruent. So, I think it might be time to get started. Let's see, what do I know from the diagram itself? Well, I know that angle QTP and angle QTR form a linear pair. And I know that because of the given diagram. That's my first box. You're going to see as I work through this, we're going to have pairs of boxes. So there'll be one over here, one over here, one over here, one over here. And as we work down the page, those will match up pretty closely. So the next thing I'm going to show, so that was the pink, QTP and QTR form a linear pair. Now let's do the yellow, QTR and RTS form a linear pair. So angle QTR and angle, don't use a plus sign here, we're not adding these things, angle RTS form a linear pair. Again, the same thing. How do we know that? We know that because it's given in the diagram. You will also see these called figures, and you will see them called drawings. Matthew calls it a diagram, so I'm going to use that. Good idea to try to match up these box sizes. Good idea to double check that your work is legible. Okay, now once I know that those two things form linear pairs, the next thing I want to claim based on that is that the two pairs of angles are supplementary. So I'm going to tell you now that angle QTP, that's a P, and angle QTR are supplementary. Let's see if we can squeeze that in over here. And how do I know that? I know that because I was told that that's what the linear pair postulate says. Two angles that form a linear pair are supplementary. Okay, that's the same thing. Remember, we're going to connect those with some arrows. Try to squeeze a little arrow in there. And let's take the next two angles. I'm just looking at these angles right up here. Let's say that angle QTR and angle RTS are supplementary. I think I'm going to want to move that. Alrighty. Excellent. Nice errors. I'm coming up with new errors every time I do this. Okay, I can do that. Let's now grab all of this and scoot it over. So we have a little bit more room. How do I know that angle QTR and angle RTS are supplementary? Well, same reason as the box on the left, linear pair postulate. Don't worry about having too beautiful handwriting over here. Linear pair postulate. And that needs a little arrow coming down from up there. All right. What can I conclude? You know what? I'm going to go back up here and check. I've been making so many mistakes as I do this for you guys. I'm going to double check. Let's just go see. I'm going to color this pink again. This was pink. And it's angle QTP and angle QTR. That's what it should say here. Good, it does. And this was yellow. And this was angle QTR and angle RTS, and that's what it says here. Okay, that's good news. Now, what can I conclude if two angles are supplementary? I can conclude that the sum of their measures is 180 degrees. So I'm going to say the measure of angle QTP plus, now I'm adding, plus the measure of angle QTR equals 180 degrees. How do I know that? I know that because that's the definition of supplementary. Put a box around that. And I have the same claim over here. The measure of angle QTR plus the measure of angle RTS equals 180 degrees. It's an 8, believe me. And how do I know that? The definition of supplementary. Put a box around that. We need some arrows connecting these. Those arrows are actually supposed to be between the boxes, not within the boxes. But I'm trying to fit as much as I can on the page here right now. This will fit on an 8.5 by 11 piece of paper, so have no fear. Now, the magic happens. I want you to take a look at this. I'm going to use some new color coding. Let's see, some interesting color coding. How about orange? Notice that equals 180. Notice that equals 180. Well, if orange equals 180 and green equals 180, then orange equals green. And so we're going to say now that the measure of angle QTP plus the measure of angle QTR, that's the orange, is equal to the measure of angle QTR plus the measure of angle RTS. That's the green. Orange equals green. That is because of the transitive property, our friend, the transitive property. Now, I know some of you look at that and you say, well, what am I supposed to do? You're not supposed to do anything. There's no addition happening here. We're claiming that there's an orange quantity and there's a green quantity, and we're claiming that those are equal to each other. Let's draw some very important arrows here. Now, I want you to notice something. I'm going to do some underlining here so we can see. I'll choose a new color for my underlining, purple. I want you to notice that on the left side, I have the measure of angle QTR. On the right side, I have the measure of angle QTR. I should be able to subtract those from both sides, leaving behind QTP and RTS as equal to each other. And let's check QTP, and RTS. That's what we're supposed to prove. Okay, good. So we're on track here. So here's what I'm going to do. Almost at the end here, I'm going to get back to my black ink. I'm going to now claim that I can subtract that QTR from both sides. Now I will have the measure of angle QTP equals the measure of angle RTS. What happened? I subtracted QTR from both sides, leaving me that statement. How did I do that? I used the substitution property. Sorry, the subtraction property of equality. Oh, in one arrow, could do it. Coming down there. Okay, that is not what we set out to prove. I want you to go back up and look. It says the measure of that angle equals the measure of that angle. We were actually supposed to prove that the two angles are congruent. Next step is definition of congruent angles, and then we'll be done. So let's say that angle QTP is congruent to angle RTS. And how did we do that? We switched each. We said the definition of angle congruence. Now what I will do is I will zoom out so that you can follow what's happening here. Because I'm done. In fact, I'm going to put a little box over here. The box says I have completed my work. That's what you can do when you're done with a proof. And let's zoom out so you can see the whole thing. All done.